Hello, you guys. My name is Omer, and I'm the owner and the CEO of Flow. Uh, our expertise is developing softwares for the industry. Our background is industrial engineering, lean, and software development. Okay, so today I want to show you this software as an example of what we can do. This particular software is taking use of RPW algorithm, which take place to optimize a production line or assembly line. Uh, the main thing we have to remember is that we have a constraint between activities. Each activity can start only after other activity finished. We have a way of setting it up, and it can be quite complicated. So let's see first the output, and then we will see the software itself, how we can use, how we can insert data, and this kind of stuff. Okay, so what we can see here in the graph, we can see the activities stacked on top of each other. Each activity have a name. We choose to insert the name as numbers. So 3 is the name, 12 is the duration, and it's in minutes. If I will change here hours, I will see the duration in hours, so it's a fraction. And I can use seconds, then the number will be larger, and that depends on how we insert the data, so it will easier for us to see. Yeah, okay, so we have the activity name, operation name, we have the durations, and we have the final setup, the optimal setup. So I want you to see now the problem, the production line. So we have it right there. Okay, oops, sorry about that. Okay, so we can see that activity 1, 2, and 3 doesn't have any constraint. We can just start them as soon as we can. And operation 2 have a duration time of 16 minutes. Operation 1 have a duration of 25 minutes, and so on. We have only 4 station. We can do the check if we can have benefit of bringing purchasing the fifth one. And we have the constraint. We can see that operation 4. So as I was saying, operation 4 have 2 constraints. We need to finish processing operation 1 and operation 2 in order to start operation 4. And for operation 5, we have to finish only 2. So let's see now how we can set it up in the software. Okay. So as we can see, we have the station setup screen. We have the operation setup screen. We set the name. I can set a new operation. I can decide on the new units. I don't have to choose all of the units to be the same. They can be different units. And I can put as many operations as I want and save. Okay. So then I have the predecessor screen. The predecessor screen is to tie between the activities. So on the left, I have the activity, and on the right, I have the predecessor activity who come before. So as I can see, operation 4 requires operation 2 to finish. And I have another line with operation 4 on the left and operation 1 at the right. So this is what we can see at the photo right here. Operation 4 requires 1 and 2. Operation 3, let's see it. doesn't have predecessor, but operation 5 have only one predecessor, which is 2. Okay, now after we understand that, we can run the algorithm. We set everything up, we can let the algorithm run, and it finished the optimization. So as I can see, what the algorithm did is described right here. And if this is not very comfortable for us to see, we can press on the button, export to text file, and we will have all the, oh, here it is, and we will have all of the algorithm steps along the way. Okay, so I won't go into details about the algorithm. I just want to, the software will make sense about what it's doing, how it's doing. So first of all, we have the definition, output, how the setup looks like. So operation 1 is a root activity, it doesn't have any predecessor. Same again for 3 and 2. Operation 4 predecessors as shown earlier. And we have operation depth. Operation depth is a part of the calculation step. And let's now see. The depth mean operation 1, 2, 3 are in depth 1. Operation 4, 5, depth 2. Operation 6 and 7, the depth is 3. And for operation 8, the depth is 4. As we can see, that's the just meaning that how many steps we have along the way. Because this example is quite easy, so it's easy for us to notice with our eyes. But if we have a lot of activities, operations, we won't be able to see this with our eyes as fast as we can see in that example. Okay, so I will continue. So we have the RPW, which is a calculation weighted duration. And actually, as you can see, operation start is not part of this example. I just insert it to see how we can use this screen. I will now delete it and run. Actually, it doesn't really matter about the calculation results because the duration is very low and it doesn't have any constraint. So we can see the output, we can see the cycle time original, we can see the final original, the final cycle time. We have some parameters. Again, if you know the algorithm, it will mean something to you. And we have the cycle per hours, which means, sorry about that. Sorry about that. I had to pause the video because I had an interruption. So we have the cycle time, which means how many units we are able to product in an hour. And we have the line gap, which is the total waste, how many minutes we are wasting in all of the line, and the efficiency with percentage. We can see operation 2 is in station A, operation 5 is in station A. Same as we see in the graph, we have it written down and all of the steps. And that's it basically. Keep in mind that we can connect this instead of be a standalone with manual insertion of activity station and operation stations and constraint. We can connect it to any SQL server or Access database. Here we are using Access database. We can create multiple lines. If I will close this one, okay, I can create new line. I give it name, As an example, we call it flow, and we see flow is a new database. Let me show on screen, add existing. And we have the new database. We can see the database name on the top. Oh, I'm sorry because I'm using a OBS recording software, so it doesn't record the top bar. Yeah, okay, guys, that's it. Thank you for watching, and take care. Let me know how you think. Bye bye.